In the last video in this series, we talked about how to access data in the Darwin FTP data repository via FTP in Python. We went through our class where we talked about how the class instantiates an FTP object, has two modes of operation, these being file, local fetch, or FTP. It also talked about how we specify analytics headers to imply the header definition for each of the files that we'd like to access, how we go about constructing the FTP in bytes objects, reading in the binary data, cleaning it, processing it, and outputting it as a data frame for further analysis. In this series of videos from here on, we're going to talk about each of the categorical data available to us inside the data repository, these being average leverage, badges, behavior, so on and so forth, all the way to winning consistency. And for each of these files, we will generate a method and a convenience method in this same class to enable you to access this data remotely via FTP directly from your Python environment without having to physically download the entire data repository that is, of course, very large. We'll start with execution analytics, and here we'll begin with order divergence. As we mentioned in the first tutorial here, order divergence is a file that contains information about the detailed divergence and latency per order. So we'll go and find this data now through Python. For this, we've created a function called getOrderDivergence that again takes a Darwin as a parameter and has a plot parameter that is by default set to true that will plot a few things as we'll discuss shortly. Now, this function will get the evolution of the given Darwin's replication latency and investor divergence per order executed by the trader. It takes in the Darwin's ticker symbol as a parameter, the plot parameter for true or false determines whether a chart will be produced for replication latency and divergence, and it outputs a data frame for further analysis as per your requirements. Each of these methods will follow a convenient structure where we'll specify the data type within the function as opposed to accepting the data type inside the function header for the time being. There are other ways to compose this function, but for the purpose of education on these tutorials, we thought that this structure would make the flow of the function a bit more comprehensible for first-time users. Data type here is set to order divergence, and we'll now use the getAnalytics function that we used and demoed in previous tutorials alongside the Darwin ticker symbol that we've taken in as a function argument. This will then produce a data frame. And inside this data frame, we'll have some information that needs some treatment prior to being used in plotting on a chart. This getAnalytics function for order divergence will give us the following information. So let's call the order divergence OD, and inside this, let's pull get order divergence. Again, for consistency, let's stick with LVS. And let's specify plot as false for now, as we're going to just talk about the data for a moment. This will return to us the data frame object inside the variable OD, and then we'll open up OD and see what it contains. OD, as you can see, has had its header definition taken from the analytics headers dictionary object in the class and assigned instrument, USD volume, latency, and divergence per timestamp. So in this series, we have instruments, the dollar volume, the latency experienced between trader and investor order replication, and the divergence experienced by the investor. There are a few analyses that we can conduct with this data. For example's sake, here we're going to plot the median order replication latency and median investor divergence experienced per order. In order for us to do that, let's go through the code that generates that for us back inside getOrderDivergence. And over here, in order to plot this, we construct a 2x1 plot where we have two charts stacked on top of each other. And in order for us to go about capturing the per instrument median order replication latency, we need to perform a pandas group by. So in order for me to explain that to you, OD, since it already contained our data frame, is where we're going to be looking for this information. If we'd like, for instance, the median order replication latency per instrument for the Darwin LVS, we're going to execute the group by as follows. Please bear in mind that this particular file only contains the last 100 trades at the present time. In order for us to calculate the median order replication latency per instrument, we're going to execute a group by using the column instrument. Inside here, we'll now get groups that have each instrument and their associated timestamps, latencies, divergences. For us to then focus on divergence, we will very simply select divergence, either using the dot or the bracketed format of accessing the column, and then we'll simply calculate the median as so. This will return to us the median divergence experienced per instrument, and if we wanted to do the same for latency, as we were initially talking about, we will select the latency column and calculate the same median. The information that you can see in this example that we use to demonstrate how to get the order divergence data into your environment, this example essentially tells us that over the last 100 trades, LVS has experienced 63 milliseconds as the median order replication latency on the ArtJPY, and the other numbers for each of the other assets that LVS has been trading. And it's been experiencing a median divergence of 0 on ArtJPY, a negative all the way through to Penta 0.7 on the NZD USD, so on and so forth. So this gives you an example of how to go about conducting some analysis with the data you've retrieved. And the median order replication latency and median divergence experienced by investors are purely examples for the purpose of demonstrating how all of this can be used. If we simply call the same function with true set for the plot variable, this time we'll have this information plotted for us in a stacked 2x1 matplotlib chart, where the median order replication latency in milliseconds has been plotted for you per instrument, sorted from highest to lowest. And the same with the median investor divergence per order, sorted from highest to lowest. In this case, the positive numbers implying positive divergence, the numbers for which there's no data implying zero divergence at median, and finally for the Kiwi dollar being the only instrument that has experienced negative divergence over the last 100 trades. This is how the information can be presented to you in this example. You are, of course, welcome to, and that's the idea, to enable you to conduct your own analyses in ways that are meaningful to your own research and strategy development. As always, if you enjoyed this presentation, please do consider sharing it with your social networks, colleagues, co-workers, and friends. And do subscribe to the Darwinex YouTube channel so you remain up to date with all future videos that will be released in this series and other topics discussed on Darwinex. Thank you very much for your attention. See you next time.